Hello again. Well, it's been a while since the last video. We've got Christmas over with and New Year over with, and as you can possibly tell, I've developed something of a under over the playpen, so I'm going to have to get back in the gym and sort of work that off at some point. Yeah, right. But what we're going to do is we're going to go over something that we've gone over before, and that's to do with scope balancing, and it's something that I've had a few questions about, so I'm just going to do a little bit of a recap and then cover those specific questions. Now, the first question that I got asked and do get asked a fair amount is this. If you remember, in a previous video we did a scope balance, so I'm not going to completely go over the scope balancing technique again, but if you remember, we put the scope into this position, so it's making a T over sort of perpendicular to the floor, and if we release those clutches it should all balance up, which, like I said, we covered before. And then I did the slight trick where if you start to put it in the orientation that you would be pointing at in the sky, everything sort of disappears because the centre of the gravity of the scope isn't quite right. And we cured that, if you remember, by just slackening the rings off a little bit and actually rotating the scope in the rings, and now everything balances, so that I can tighten these rings up like so, release all clutches, and the scope will it'll balance anywhere, wherever I want to put it, it'll stay put because everything's balanced. The centre of gravity of the tube is balanced, it'll just stay wherever it is that I want to put it. Now, the first question that I've been asked by quite a few people is this: does this degree of balance matter if you're only using the scope visually? And the answer is no. It's mostly for imaging, and I'll go into that a little bit deeper very shortly while I answer a couple more questions. But what I have been asked is, by visual astronomers, when they're using a Newtonian like this, is it then okay to rotate the tube in the rings to make the viewing position sort of more accessible? And the answer to that is yes. You know, the amount that you're going to knock it out when you're doing visual isn't a problem. It's not going to have any effect whatsoever. So if you change the scope to a position that, you know, some sort of a viewing position of whatever it is that you're looking at, it's quite alright to then rotate in those rings to get yourself a decent viewing angle. So visual, it isn't a problem at all, just rotating the rings. Just make sure that you do the basic balance first. That's the first question over with. The next one, and it's one that quite a few people have asked, and it is a little bit confusing, I suppose, and it's to do with precise balancing when you're imaging. And people have read sort of descriptions of how to offset the balance a little bit, because you do need actually to balance and then upset the balance when imaging, which I'll explain sort of more deeply in a couple of minutes. But one of the phrases that gets used to explain sort of how to offset the balance is to make the scope east heavy. And people are thinking, like, east heavy, what does that mean? So I'm going to show you. Let's imagine that your scope is in its home position. So let's just adopt a home position with the scope, like so. Now what we do is we get our objects that we're going to be imaging, and the scope slews to wherever it's going to slew to. So let's just say, just point it at some sort of random area like so, and that is now our viewing position, that it's pointing at the item that it is that we want to actually, you know, to image. What you do then is you stand behind your mount like so, and if you're facing north, which you will usually have a leg on a tripod, I'm using a column mount, you'll usually have a leg on a tripod that's got an N on it. You know, it's the actual part of your mount that's facing north. So stand behind your mount facing north. When you're facing north, what you've got to then assume is that south is behind me, west is on my left, and east is on my right. Now, because east is on my right, that means that the scope itself in this position is in the east, so this wants to be slightly heavier. So what we do then is just slide the weights up by maybe an inch, maybe sort of 30 millimetres. That's all you need to do. You're making the mount east heavy. Obviously, if you change perspective, you know, if you slew then to another object, and this time your scope's on this side, your weights are on the opposite side, then obviously you just do the opposite, so that you're making the whole assembly east heavy, and that's what east heavy means. Just to recap, point the scope at the object that you're actually going to be imaging, stand behind the mount facing north, south behind, west on the left, east on the right. The part of the assembly, either be it the weights or the scope, is the heavy part, so obviously slide the weights in that position. Now another thing that also confuses a few people is in the declination of the mount, which way do you do it then? Because like a lot of the descriptions say, I prefer to make it camera heavy. Well, that's alright, except if you've got a refractor, the camera's at this end, and if you've got a reflector, the camera's at this end. So it sort of, you know, one goes against the other. So if you've got a reflector, I tend to go mirror heavy. So that back end, just do the same for that. Just slide the telescope in the mount a little bit, make it slightly mirror heavy. And what we're going to do next is just explain again why, with the help of a couple of props. Okay, the reason why we offset the balance is this. If you imagine that your mount is driven by a motor and it works through a gearing system, which then drives either the right ascension or the declination on your telescope. Obviously the gearing system in your mount is a lot more complicated than this, but we just don't have the props budget here, I'm afraid, at Shed Towers. But what you've got to assume is that the gearing isn't exactly perfect. There will always be some play somewhere in that gearing system. Now, if this is your telescope side and it's perfectly balanced, what it's free to do now is to basically float about within that area of play, whether it's by wind or whether just driving the telescope using the motor just happens to bounce this section as it drives it, you know, sort of it starts to just oscillate that little bit as the motor's driving it round. That will then obviously cause you some unnecessary movement in your imaging. So what we do is, by offsetting that balance and making it east heavy and mirror heavy or camera heavy, is that this gear, because the balance is offset, this now is trying to rotate in this direction. Obviously it can't because the gears are in mesh, but what it does do is it will fight now and push against the section of the motor that's driving it, which means that now there's no play. The wind won't blow that amount of offset with the weight that's in there, and that's why we do the offsetting of the balance when we're imaging. Right, as I said at the beginning, it is going to be a short one, and that's about it for this one, and hopefully now all your questions about balancing have been answered. And once again, thanks for watching.